All right, ladies and gentlemen, so today we're going to be working on taking a look at some graphs and then trying to get some information from those graphs about our proportional relationships. So we're going to start off kind of tying everything together and making sure that we understand what is going on here. So it says Grandma's special chocolate chip cookie recipe, which yields 4 dozen cookies, calls for 3 cups of flour. Using this information, complete the chart. So the first thing they ask us for is to make a table. So I'm going to be comparing how much flour we have and how many cookies. So it's going to be cups of flour compared to the number of dozens of cookies. Now you could do this for just the actual number of cookies, but then your numbers are going to get a little bit bigger. So we know it tells us that we have 3 cups of flour and it yields 4 dozen cookies, right? I got that information from up here. So if I double that, if I have 6 cups, I should be able to get 8 dozen. If I do another times 3, so if I have 9, then I'm going to get 12 cups. And if I had 12, I would get 16. So I think that's good for that. Is the number of cookies proportional to the amount of flour used? Yes, because BC, the unit rate is the same. Because if I go through and I actually write this, this is going to be 4 over 3, 8 over 6, which is 4 over 3, 12 over 9, which is equal to 4 over 3, and 16 over 12, which is 4 over 3. If you divided that out and got it as a decimal, it's going to be 1.3 repeating, which is okay. What is the unit rate of cookies to flour? Well, we just figured that out. 4 over 3. And what is its meaning in the context of the problem? It means 4 dozen for every 3 cups of flour. All right, that's what that means. Model the relationship in the graph. So when we do our graph, right, this is always our X, this is always our Y column. So down here at the bottom is where we're going to have cups of flour. And our Y-axis is where we're going to have dozens of cookies. I have to put some numbers on here. I'm just going to count by ones. I think it pretty much works for this. So we're going to have, so this is 0, so we're going to have 1. I'm only going to fill in every other number though. 4, 5, 6, 7, 8, 9. I just said I was filling in every number and I put the 9 in. Sorry. How about 10? And then I went to 12. On this side, again, same thing. I'm going to count by ones, but I'm only going to fill in every other number to make it a little bit easier. So here's 0, 1, 2, 3, 4, 6, 8, 10, 12, 14, 16. Okay, so now we have to take and we have to turn these into points. So I know that this is 3, 4 on my grid. So that means I'm going to go over 3 and up to 4, and there's my dot. 6, 8. 6, 8 is going to be right here, and then we have 9, 12, and then we have 12, 16, and then you do have to actually connect those, hopefully with a nice straight line. Apparently I misread that. You should always use a ruler or some type of straight edge, whether it's the edge of your phone, your calculator, binder, something. So there's what it looks like on the graph. Does the graph show the 2 quantities being proportional? Yes. Explain. It's a straight line, right? So this is all from the first part of the chapter through the origin. So now they want us to write the equation that can be used. You can use Y and X. You can use cups and D, C and D for cups and dozen. It's whatever you would like. I'll show it both ways. So it's always, our general form is always y equals kx. K is your constant of proportionality or unit rate. Right, that's what that's called. So my equation is going to be y equals 4/3 x. If you want to talk about cups and dozens, so this was y was our dozen, 4/3 c, x was our cups. And again, I got that from up here. Flour, cups, dozens of cookies. So this is everything that we've been working on being able to do. All right, let's take a look at another problem here. So example 2, below is a graph modeling the amount of sugar in cups required to make Grandma's special chocolate chip cookies. Record the coordinates from the graph. What do these ordered pairs represent? So the coordinates from the graph, right, I'm just going to read the number. So this is 2, 3. This next one that they show is over 4 and it's up 6. This one over here that they have, let's see, that's 5, 6, 7, 8, 12. And let's see, we'll just take one more. 12, 15, 16, 17, 18. So what do these represent? These represent the amount of sugar needed for the dozens of cookies. I know I didn't leave you guys a lot of space here, sorry. Grandma has 1 remaining cup of sugar. How many dozen cookies will she be able to make? Plot the point on the graph. So that's telling me, right, here's 1 cup of sugar. So here's the point where it touches the graph. So how would I figure that out? Well, I know if she has 2 cups, she can make 3 dozen cookies. So they're really asking me to do a unit rate. So 3 divided by 2 is going to be 1.5 dozen cookies. That's your unit rate. How many dozen cookies can Grandma make if she has no sugar? Well, if she has no sugar, she can't make any cookies. None. 0. Can you graph this on the coordinate plane provided above? Yep, it's right here. There's the point. What do we call this point? That's our origin. So from a graph, you should be able to find the origin. You should also be able to find the unit rate because it's where the x column, whatever's down here, is going to give you 1, right? This is your independent variable. This is your dependent variable. All right, next one. The graph below shows the amount of time a person can shower with a certain amount of water. Can you determine by looking at the graph whether the length of the shower is proportional to the number of gallons of water? Yes, right? We keep doing the same thing over and over again. You should be able to handle this. Explain how you know. So yes, straight line through the origin. Okay, it's a straight line. It goes through the origin. How long can a person shower with 15 gallons of water? So I'm going to look here. These are counting up by 5s, 5, 10, 15, 20. So here's 15 gallons. If I read up, that's going to tell me where it intersects the line. Is going to tell me how many is that minutes? Yes, minutes, sorry. So they can shower 5 minutes. How long can a person shower with 60 gallons of water? So I'm going to do the same thing. Here's my 60. I'm going to see where it hits the graph, and I'm going to read over. So that should be 20 minutes. What are the coordinates of point A? Well, let's see here. Point A, so again, we're counting by 5, so it's 25, 30. And if I read over, it's 10. What does that mean in the context of a problem? So with 30 gallons, it's a 10-minute shower. Okay, can you use the graph to identify the unit rate? You could. This one would be a little hard to read since one isn't exactly on the graph because we're counting by 5s. So this one would be a little bit hard, but I can at least figure it out from the other part, because then it says write the equation to represent the relationship between the number of gallons used and the length of the shower. So we take any one of our points and you write it as a fraction, because you remember our constant, our general form, y equals kx. K is always y over x. So 10 over 30. I'm going to choose to keep this as a fraction, which is 1/3. So y equals 1/3 x. If you wanted to do it using minutes and gallons, the number of minutes is 1/3 times the number of gallons, right? So this is either or. You can write it either way. All right. Any questions? As always, bring them to class, but this was really just kind of a lot of review. I know there's a whole other page, but we'll talk about that one together in class. All right. Any questions? Bring them with you.